Okay, so this is my setup. This is the turret that I'm making, and now I'm just demonstrating the PID function of it. So that's not all of it. It's just a part of it. So this here is the encoder on the motor, and this one sends the signal to the computer about how many rotations have it, like the position of the shaft of the motor, and like how much it has rotated. Using this information, the microprocessor calculates that signal, and it can make it stay at one position like this. So let's talk about the basic working principle of my PID system. First off, you need to know that we want our motor to turn to a certain angle. So let's suppose we want it to go to 0, and now it is at -10. So the PID system takes this input of where the motor, where the angle is now, and use that input to calculate what the motor should do to compensate, to get it to where you want. So PID is actually composed of 3 parts, which is the P proportional, the I integral, and D derivative. Each plays a role in this system. The P is the part that adjust the motor to go to where it should be. If it is at -10 now, and if the motor turns right and it will become smaller, then the P part will tell the motor to turn right. And if it needs to turn left, then the P part will tell it to turn left. The bigger the error is, the bigger the P part will tell the motor to spin. The more power the motor will spin in that direction. The I part is the part that is responsible for making the system more accurate. Long story short, but it's the accumulation of the error. So if you're a bit, for example, this one is without the I. If you're off by a bit, the I part will accumulate gradually, and it will become a big number enough to change the motor, and it will cause it to be more accurate. That is basically it. And the D part is the part that stops the system when it is approaching the target. For example, as you can see here, without the D, it will keep oscillating because there's momentum between each of the oscillations. To solve this problem, we have to add a D, which tells the motor to slow down when it's approaching the target. If you want to see more details about how I did the code, you can check out my other video about the programming stuff. So thank you.